So our first step here to find the arc length, what do we have to do? Find the circumference. How do we do that, Drew? How do we do that, Drew?
I don't know.
Circumference is 2 pi r, or pi times diameter, right? So what would be the diameter of this one? 24. So pi times 24. Otherwise known as 75.40, about. Now what? Yeah, it's 40 over 360 is equal to that arc length over 75.40. If you cross multiply and divide there, you're going to get that this is 8 point what? 38. 8.38 approximately. 378, something like that. Inches. How many of you had 8.38, 8.37 inches? No, you didn't. For the sector area, what do we have to find first? Area of the whole circle. How do we find the area of the circle, Sam? Pi r squared. So in this case, that'll be pi times 12 squared. $452.16. 0.1, yeah, if you use the pi key, it'd be a little bit larger than that. Same difference. And that's going to be inches squared. So now for the sector area, we do the same thing. 40 out of 360 equals how much out of 452.16? Which is what? 50.27 about square inches. 2.4 if you use the 3.14. Any questions on how to do those?
What happened to your hair?
What? Couldn't hear you. Sorry, can you yell louder?
So, let's say that we have a triangle where we have... Okay, so let's say we've got a circle here. And we have a central angle here of 60 degrees. And a radius of 4 feet. I want to know the area of that segment. How can I find the area of that segment? Okay, so let's find the area of the whole circle first, which is going to be pi times 4 squared, otherwise known as about 50.24 square feet. Yes? No? Okay. Now I'll find the area of the sector, which is 60 over 360 equals blank over 50.24. And if we cross multiply and divide there, we are going to get 8.37 something, 8.37 it looks like. Feet squared, yes. So 8.37 square feet. That's the whole sector though. How do I find the area of the triangle? Well, I know those two sides are equal, don't I? So what do I know about these two angles? They're equal. How big do they have to be? Well, we know that the whole triangle adds up to 180, right? So 180 minus 60 is 120. That means those two have to add up to 120. You divide by 2, they're each 60 as well. Which is telling us that this is an equilateral triangle. Now we could use Hero's formula where you have find the perimeter and go through all that crap. But we discovered an easier way. We can find the height here by doing what? If I draw that in perpendicular to that chord, it cuts the chord in half, doesn't it? That would be 4 feet total, so that makes this 2 feet, correct? Does that make sense? This would be 4 feet, this would be 4 feet, this would be 4 feet because it's an equilateral triangle. If I draw in that perpendicular to a chord, it cuts the chord in half, so that's 2 feet. Which makes this here the square root of 4 squared minus 2 squared. You see where I got that? A squared plus B squared equals C squared, but I had C, so it's C squared minus A squared equals B squared. So that's going to give us the square root of 12, 3.464. So I have a height of 3.464 feet. So the area of that triangle is just that times 4 divided by 2. Base times height. So 6.93 is the area of the triangle. Everybody, I'm going to pause for a minute. Everybody see where that 6.93 came from. I have a base here of 4 and a height of 3.464. So 3.464 times 4 and divided by 2. It's a triangle. Any questions on how I got that? Any questions on how I got the 3.464? Okay, so now what do we have to do? Yeah, subtract 8.37 minus 6.93, and we get 1.44 square feet. Not so bad. Sound like fun? Good deal. What part?
Getting that last area.
The 6.93 or the 1.44? This here? Because this triangle here, if I draw it out, all the sides are 4. And this here we found to be 3.464.
So you subtracted the 6.93, which is the area of the triangle. You subtracted that from the center.
Yes. Yeah. See at the 1.44.
Makes more sense.
Okay. You bet. So let's say we have an arc here that's 38 degrees and an arc over here that is 86 degrees. How do I find the measure of that angle? What's that? Well, if the angle were at the center of the circle, a central angle, the angle would be equal to the arc, wouldn't it? If the angle were on the circle, an inscribed angle, it would be half the arc. But when it's in the middle of the circle like this, but not at the center, it has two arcs that are not equal. That angle is found by averaging the two arcs. 38 plus 86 divided by 2. What's that come out to be? 62 degrees, look right? Somebody average those up for me. Now make sure you do 38 plus 86, hit equals, and then divide by 2. 62 degrees. Okay, so I want you guys to find this angle. If this is a 32 degree arc, and this is a 78 degree arc. Find that angle quick for me. 55? Very good. It is just going to be 78 plus 32 divided by 2, which does come out to be 55 degrees. How many of you got 55? Good deal. You look confused, Michael. You got it? All right. Given this angle here is 70 degrees. What's this angle right here? This is the center of the circle, by the way. Well, if that's a 70-degree angle, what's our arc out here? 70-degree arc. This then is an inscribed angle off a 70-degree arc. An inscribed angle is always half the arc. Very good. It's 35 degrees. That is the center, yes. Find that angle. Now I'm going to do a little highlighting here for you. That angle is formed by those two lines right there. So that angle is going to be found by doing what? Averaging this arc with this arc. Do I know the size of this arc?
Yeah.
8 degrees. Do I know the size of this arc? That's 11 degrees.
Oh, it's 11.
Yeah.
That's like 1.
So that's going to be 22 degrees, right? So that's an inscribed angle. Its vertex is on the circle instead of on the center. So the arc is double the inscribed angle. Or the inscribed angle is half the arc, either way. So I've got 22 and 88, which makes this 55 again. Everybody catch that? Okay, because this arc can be formed by is off of this angle. This is an inscribed angle because its vertex is on the circle. This is an 11-degree angle. So the angle is always half of the arc if its vertex is on the circle. Just like up here. This is a 70-degree arc. This is a 35-degree angle because the vertex is off the it's off the 70-degree arc, but the vertex is on the circle, so the angle is half the arc. So the same here. This time we had the angle, but we know it's still half the arc. So an 11-degree angle gives us a 22-degree arc. The hard part is just seeing them. Let's say that this angle here is 58 degrees. What's this arc going to be? Well, where is the vertex of this angle? It's on the circle, right? If the vertex is on the circle, the angle is half the arc. So it's 116. 58 times 2 is 116. Has to be the arc. What's that?
Yeah.
You sure?
Yes.
Okay. So now we have two secants intersecting outside the circle. This is a 34-degree angle here. This is a 72-degree angle here. I want to find this angle out here. Do you guys remember how to do that? It's now the difference between the two arcs divided by 2. If the vertex was inside the circle, you added the two arcs and divided by 2. The vertex is outside the circle, you're going to subtract. The 72 degrees minus 34 degrees over 2. That is what? 38 over 2, or 19 degrees. Does that make sense? That's it?
Perhaps you turn it to rads instead of degrees. Should be about somewhere.
That wouldn't change anything he's doing here. Here, let me take a look at it. So let's try a fun little example here for you. Yeah, we'll try that again. So if I'm going to give you that this angle right here is 41 degrees, and this angle right here is 13 degrees, can you find this angle right here? I'm going to give you a minute in your notes to see if you can figure that out. So looking at this, what's this arc here have to be? 26 degrees. Good. What's this arc over here have to be? 82 degrees. So this is going to be 82 minus 26 over 2, which is what, 28? How many of you came up with 28 degrees? Good deal.
No, that's weak. Oh, you're right. Giant. Yeah.
So if that's the center of the circle, that's 9 degrees. I want you to find this angle right here. So see if you can figure that one out. Okay, so did you manage to find this arc right here? Well, whatever that angle arc is, I'm going to call it x. X minus 21 over 2 has to be 17, correct? So I'm going to times 2. So x minus 21 equals 34. And then I will add 21. So x equals 55. So this arc is 55 degrees. So now, to find this, did anybody find an answer for the central angle, by the way? What'd you get? Perfect. What's this portion of that arc have to be? 18 degrees, because this is 9 over here on the inscribed angle. And these are additive or subtractive in this case. 55 minus 18 leaves this with being a 37 degree arc. And that's its central angle, so that's a 37 degree angle. You guys starting to see it all now? All coming together? A lot of little pieces, a lot of little rules that you have to fit together in these. Any questions? You want to see another example?
Yeah.
Why not? Oops. Come on. Find this angle right here. I'll give you a couple minutes to find it. The key to this problem is anytime a radius, since this is the center, anytime a radius touches the circle at a point of a tangency, the radius and that tangent line form right angles. So those two both have to be right angles. Now if those are both right angles, we now have a four-sided figure here that we know 3 out of the 4 angles. The angle sum for any four-sided figure is what? Yeah, 180 times the number of sides minus 2, or 4 times 4 minus 2, which is 2. 360 degrees. So this angle is 130 degrees, which makes this arc 130 degrees. Which means we can find this arc because 130 minus, if I call that x, x over 2 has to equal 50. Everybody see where that came from? Because the 50 here, right, is off of these two secant lines. So that 50 came from taking this arc minus this arc and dividing by 2. So 130 minus x divided by 2 has to give us that 50 degree angle. Does that make sense? Because if all I had was this, right? This is 130 degrees. That's x, and this is 50 degrees. The 50 degrees is found by taking this arc minus that arc divided by 2. 130 minus x divided by 2 gives us the 50. So if I solve that, I multiply by 2 and then subtract 130 and divide by -1, I get that x equals 30 degrees, correct? 30 degrees. So that is 30 degrees here. So that means that this has to be 15. Yeah. No, it's 130 minus x. It would have to be 130 minus 30 would be 100 divided by 2 would give you 50. If I were going to solve that, 130 minus x over 2 equals 50. I'm going to multiply by 2. So 130 minus x equals 100. And then I would subtract 130. So negative x equals negative 30. Then divide by the negative 1. X equals 30. So x has to be 30 degrees. So if that arc's 30 degrees, this inscribed angle has to be 15. A lot of happy little pieces that have to fit together here, aren't there? I'm going to let you guys try to practice some. In your book, on page 550 through 552, this is exercise 25-13, 1 through 11. And then on page 557 through 560, exercise 25-17, 1 through 11. And we'll leave it at that for now. Practice the angles and stuff.